So hello everyone. So here I am with the experiment of digital communication. So first experiment is the sampling and reconstruction. Okay, so we are going to perform sampling of an analog signal, and afterwards, when the samples have been generated, we will reconstruct the signal by help of those samples. So for that thing, firstly I am going to take here the AC voltage source. This would be my analog signal. And for sampling thing, we are going to take here the pulse thing, that is the clock voltage. Okay, then we are going to perform the sampling by the help of a transistor. We would take NPN transistor. Just see here, I have already once done this experiment. Okay, so now we'll take other components such as resistor. One kilo ohm resistor I will take. I will also take for regeneration. We will take ground capacitor, resistor also, and ground we will take for this circuit also. So in source we will get the ground here. Okay, so now firstly I will sample the signal. Okay, for sampling thing we'll just connect this circuit firstly. Just copy one ground from here and paste it here. I have connected this analog signal with 1 kilo ohm of resistor, and then I am going to connect it here with the transistor. Okay, so this one is the base, the emitter, and the collector. So we have connected our analog signal towards the collector side. So I'm going to connect this clock source also, the negative to the ground, and the positive one I'm going to connect with 1 kilo ohm resistor. So I will just copy this 1 kilo ohm resistor from here to here. And this I'm going to connect to the base of this transistor. Actually, transistor is used as a switch to turn on or to turn off. Okay. So this thing we have done, and here I will just connect one more 1 kilo ohm resistor here. So I'll copy this 1 kilo ohm resistor and put it here. Just rotate it clockwise or anti-clockwise, and just connect this thing to the ground. Okay, from here we will take the output from this part. Okay, that is the emitter part. So just use an oscilloscope here, connect this thing here, and the negative of it could be connected to the ground. So I'm just going to copy the ground from here, and I'm pasting it here. So done. Now I will simultaneously check the input and the output. Okay, both. So one channel of the oscilloscope I would connect here with my input, and the negative of it will be connected to the ground. Now run the simulation. Just check here the output. I will firstly reverse it. I will decrease the voltage divisions here. Okay, it doesn't look very good kind. Okay, the reason is that I haven't changed here the value of voltage and frequency. Okay, so firstly just change here the voltage. This is 5 volt, so I would make the signal to be 5 volt only here, so it would be good. Now as the sampling frequency says that the sampling frequency would be greater than twice of the input frequency signal. Okay, so this input frequency signal is 1 kilohertz. So I am going to take here this frequency to be more than twice of it. Suppose just take 10 kilohertz here. Okay, now it looks good. Now run this simulation. Okay, now again both of the input and output are in red color. So I will just change the color of this thing. I will change the color of my output here by double clicking on this wire. Just click on this color button. I am going to take a violet one. Click on OK. Now again run the simulation. Now you can see here the red one, this one is the input signal, and this blue one, it is the violet one is the output signal. Okay, that is the sampled part. So firstly just stop the simulation, scroll this thing here, just decrease more of this time basing. Okay, now you can see here the samples. Okay, for every positive and negative part we are getting the samples here. Okay, these are the samples. Okay, so now this thing we have done, we could see here easily that we have successfully done the sampling here. Okay, these are the samplings, these violet ones, and this red one, as you already know, is the input signal. Okay, so here are the data of the signals. Now we can regenerate the signals. Okay, so if you want to see that whether my this input signal is having 1 kilohertz of frequency or not, you could just use your cursor, just move your cursor from this point to suppose this point, click on this red button. It is at the highest point, this cursor, and this cursor is again at the highest point here. So just check here the difference between the cursor, this horizontal axis, since it gives time difference. So just check here the time difference from this part to this part. It would be one oscillation. So T2 minus T1 is equal to 1.004 millisecond. So it is about 1 millisecond. Okay. And if you inverse this 1 millisecond, you will definitely get 1 kilohertz of frequency. Okay. Now again, if you want to see the difference of time in the pulse, you could also see here. You could move the cursor to this part and this cursor to this part. Okay, now these are the two cursors, these both are at the end of both the pulses. Okay, so here you can see the time difference is around 49.24 microsecond, that is around 50 microsecond. Okay, so 50 microsecond is the pulse width here. Okay, so if you want to see the time difference between two different pulses, could just move your cursor from here to here. Okay, it looks fine. Now you can see here the difference between the two pulses is also around 49.24. So this is minus 49 because it is T2 minus T1. So we are subtracting T1 minus T2. Okay, that's why it is minus 49. If I will move this first cursor to here and second cursor to here, it will become plus 49. Okay, so this minus sign doesn't make any difference here. Okay, it is just showing that here T1 is greater. Okay, so no issue in that thing. Okay, so here we have done this part. Okay, now we will regenerate the signals. Okay, so I will just close this thing, and now for regeneration I am going to use low pass filters here. Okay, so for that thing I will use, firstly I will delete this these wires, and then I will just use here a capacitor and a resistor. So I will firstly introduce here a capacitor. So the capacitor value I would take around 0.01 microfarad. One capacitor and one resistor here I would take. So I'm not going to take the resistor. I will just copy this resistor from here. I would paste it to here. Okay, done. So I will just rotate this thing. I will move this thing here. Okay, now it looks okay. So I'm going to connect this low pass filter to this portion. Okay, so that the input for the reconstruction circuit would be taken from the output of this sampling circuit. Okay, so I'm going to do two times this thing, low pass filter. I'm going to use it two times. So I will just copy whole of sorry, not this thing. I'm just going to copy this thing two times, sorry, one time. Control C and Control V here. So whole of these things has been copied. Join it here. Okay, it looks good now. Okay, so I'm going to change the value of this register. I have just double click on this thing, okay, to change the value of this register. You could simply double click on any register, capacitor or any other thing, okay, to change their values. Register, capacitor, inductor or any other. So this thing I have done, and I'm going to connect this part to the ground here. So I've connected this thing to the ground here, as these all things are shorted to the ground. So the other end of the capacitor is now grounded successfully. Okay, so now this thing I have done. Now I will just take the output of the my regeneration circuit from here across this capacitor. Okay, so I would use here. Okay, this B channel is used as take by for taking the output of the regeneration circuit. I will just change it to this color. Suppose take here violet only. Now I would take one signal to be from the input part. Okay, so now I will just run the simulation here and check the oscilloscope. So here are my result. So firstly, I'm just going to increase my time division. So you could look here, the red one is the input signal and this violet one is the output signal. Okay, so in order to see that we have successfully reconstructed the original wave only, we need to check the frequency of the output wave. Okay, as we can see simply by here that channel A and channel B scale division is 2 volt. Okay, so here we can see that channel A is having very high voltage. That means we are getting very low voltage in the output. So that's okay, we can amplify the signal. Okay, but we need to say that frequency has not been changed. Okay, if frequency has been changed, then the information will get distorted. Okay, so for that thing, firstly, I'm just going to pause this thing, and then afterwards I'm just going to increase here, sorry, decrease here the time division. Okay, now I will check the frequency of this violet one. Okay, okay, it looks meshy, so I will just delete this first connection here. Okay, now I will again run the simulation. Now it's look okay. I will check the frequency of this signal. Take this to be the topmost part, and one cursor to this part. Okay, now it looks nearly good. Okay, so we can look here, the time difference for the from one crest to one crest is 1.01 microsecond. That is approximately 1 kilohertz. So here we can see that 1 kilohertz of the signal has been transmitted, and after reconstruction also we have got 1 kilohertz of signal. Okay, so this confirms that yes, by the help of sampling theorem, according to the sampling theorem, when we work, we can successfully get samples of the signal, of the analog signal, and then afterwards we can regenerate those samples again back to the original signal. Okay, here we have demonstrated this thing. So this was the end of the experiment.